Chip.
Hello, everyone.
We are Team Bear.
Hey, this is Charles Brady. This is David Erickson.
This is Ashwin Aravindan.
And this is Aaron Riesfeld.
So through our shadowing with physical therapists, we found that one of the major problems they had was this plastic goniometer you can see pictured here on the left. Basically, the goniometer does not get accurate measurements, and it cannot be used from therapist to therapist reliably. Also, as you can see in the picture here, it requires 2 hands to be used, and it makes the patient hold the position while the therapist is taking the measurement. Also, as you can see on the right, dynamic stretches and exercises are an important part of rehabilitation. The goniometer does not really allow for measurements to be taken on the fly, and it definitely hinders the ability for a therapist to track this motion. So, with these problems, and because of the fact that knee injuries are 15% of all sports injuries and are huge joints that people care about, especially for marathon runners and anyone else, we've come up with the Bear in Mind system. Now, this brace that you see here is functioning to solve our goal of providing diagnostic information to promote optimum functionality of the knee.
All right, so let's talk a little bit about the actual system in the Bear in Mind system. First of all, we started by trying to make these flexible sensors that you can see in the top left picture here. Now, they were supposed to be able to detect bend angle, but unfortunately they were nowhere near as accurate as we were hoping, none of the 50 that we made. So we decided to take a different route. We moved on to this potentiometer with a rigid brace system that you can see in the bottom left. Now, this actually provides very accurate angle measurements and is our current prototype. You can test it right outside. Skinny legs. 15-year-old knee brace. So there was actually a lot of system development and programming involved in this project as well. In the top right, you can see the PIC microcontroller that we used. This was used to collect the data and push it to MATLAB on a computer where it could be plotted and other useful information could be determined. Finally, we have the beginnings of a smartphone application, which you can see in the bottom right. Ideally, this would take the place of MATLAB in terms of user feedback, plotting, all of that useful data in general.
So obviously one of our main goals was to take an individual and capture his or her range of motion over time. So here's a screenshot of a graphical user interface that we put together in MATLAB to kind of automate this process. So we would upload the data, as can seen here in this blue data graph, and different fields would populate with different diagnostic information. This graph is actually Ashwin here. We strapped on the brace to Ashwin and had him walk about 20 feet. The data went down here because we had a wire come out, but once we plugged it back in, everything was good to go.
So here's a list of stuff that we can do in the future if we decide to move forward with our project. The first would be to make it wireless so that we don't run into that kind of situation again and have wires hanging out everywhere. And then second, we'd like to take all this technology and incorporate it into a sleeve so that we could use fabric sensors to basically collect the data that our potentiometer is collecting right now. And lastly, we'd like to finish up our smartphone applications so that people can basically collect real-time data as they're performing exercises instead of having to upload it into a MATLAB later.
So here's just a quick commercial. It sums everything that we've done this semester. All up.
You ever want to sleep so much you can barely feel it when you're moving your knee? You're getting data and you can't even see it. Got that full range of motion, yeah, those angles, we can get them now. You're tracking motion while you're looking at it. You thought you hit it, thought your movement would show it. But your therapist will see missing action in your knee. What you using? The bends, average, maximum, steps, graphs, angles over time. All data will be in the motion that we're getting. It's a tool of the future. It helps you out. Keeps you on your feet so you can do your thing. Yes, you're feeling pumpy every day. Moving and moving. Crazy to think of, it's a better way to complete records of your motions that you want to know. Updated every time. You won't need another thing. Bear in mind it's like a game, so just put it on and you get to watch your knee on the phone screen. Guess that's why they made this phone app free.
In all seriousness, we would very much like to thank our senior design professor Andrew DeMeo, Jimmy Diefendorfer, our mentors Steve Callender, Flo Moses, and Jim Flanagan. Thank you very much.
If you guys are interested in seeing or hearing the rest of the song. We're going to have it out playing. There's another 2 verses.